Drying up. You know when something is wet. It is covered with water or it is soaked up a lot of water. When it rains, everything outside gets wet. When you go swimming, you and your swimsuit get wet. Clothes are wet when they come out of the washer. A dog is wet after a bath. But things don't stay wet forever. Things get dry, often by themselves. An hour or two after the rain stops, porches, sidewalks, and plants are dry. After a break from swimming to eat lunch, you and your swimsuit are dry. After a few hours on the clothesline, clothes are dry. A dog is dry and fluffy after a short time. But where does the water go? This caption shows you can't see water vapor in the sky. So the water evaporates. Important word. When water evaporates, it changes from water in its liquid form to water in its gas form. The gas form of water is called water vapor. The water vapor leaves the wet object and goes into the air. As the water evaporates, the wet object gets dry. What happens when you put a wet object in a sealed container? It stays wet. If you put your wet swimsuit in a plastic bag, it's still wet when you take it out of the bag. Why? A little bit of the water in your suit evaporates, but it can't escape into the air. The water vapor has no place to go, so your suit is still wet when you get home. Have you ever seen water vapor in the air? No, water vapor is invisible. When water changes into vapor, it changes into individual water particles. Water particles are too small to see with your eyes. The water particles move into the air among the nitrogen and oxygen particles. When water becomes part of the air, it is no longer liquid water. It is a gas called water vapor. Surface area experiment. Julie and Art want to find out how surface area affects evaporation. They decide to do an experiment. They have some plastic boxes to put water in, some graph paper, and a set of measuring tools. They're ready to start. So this is something similar to what we did in class. Julia has an idea for measuring the surface area of each box. She traces around each box on graph paper. She uses a meter tape to measure the distance between the lines on the graph paper. The lines are 1 centimeter apart. The two students number the boxes. The box with the smallest surface area is number 1. The box with the biggest surface area is number 4. Then they measure 50 milliliters of water into each box. They place the 4 boxes on the counter by the window. 1 week later, Julie and Art measure the amount of water in each box. Box 1 has 46 milliliters. Box 2 has 42 milliliters. Box 3 has 34 milliliters. And box 4 has 18 milliliters. Art thinks about the results. It seems that the surface area of the water in the boxes has an effect on the evaporation. But he isn't sure. Julie suggests organizing the results of the experiment. Students decide to do the following. Make a T-table to display the data. Make a graph of the data. Describe what they learned from the experiment. Can you help Julie and Art use the information they gathered to write a report about the effect of surface area on evaporation? Be sure to include the 3 kinds of information listed above. So I'd like you to complete that in your STEM notebook at home. Thinking about the experiment, what additional information would be useful to better understand how surface area affects evaporation? Thank you for reading along. Keep up the great work, scientists.